Okay, so the hardest part about this is looking at, are we given a function or are we given the derivative function? Okay, next class we're going to talk about second derivative functions and what that tells us about the first derivative and the function. Okay, today we're just talking about first derivative, everything with the first derivative. So if I'm given a picture, this picture right here, f of x, consider the function, what intervals is it increasing and what intervals is it decreasing on? Okay. So intervals that it is increasing on is anything that is obviously going up as you go to the right. So all your positive, or as you go to the right, your y values are increasing, right? So that would be like this piece right here is positive. Where's another positive piece? Yeah, 7 to, actually that's going forever, right? That arrow means infinity.
And beyond.
And then decreasing intervals would be anything that is going down, right? All of your y values that are getting smaller. So there's kind of two pieces there that are increasing, two pieces there that are decreasing. So then back to like algebra 1, we got to say, what is the intervals that those are? Okay, all of my x values that have y values that are decreasing or y values that are increasing. So my increasing values are anything from 2 to 5
Is this a bracket?
and 7 to infinity. Okay, we could also say bracket 2 to 5 and bracket 7 to infinity. Okay, infinity obviously we can never reach, so infinity and negative infinity have to have parentheses, but anything else, when you're just talking about increasing and decreasing intervals, it doesn't matter if you include the number or not include the number, because we're looking at the interval. We're not looking at, okay, at the point 2, is the point 2 increasing or decreasing? That's not what we're looking at. We're saying from 2 to 5, it's increasing as you get further and further to the right, okay? So decreasing, again, you can either write it with parentheses or brackets. I'm starting where on the very far left? -3, and it has a point there, so that means it's stopping at -3, going all the way to 2, and I'm including from 5 to 7. Okay, you could also put brackets if you'd rather, so -3 to 2, and brackets 5 to 7. So that's if you're given a function f of x. Okay, this whole bracket underneath basically just says what I just told you about parentheses versus brackets. Okay, you are not actually asking, or saying that at that specific point it is increasing or decreasing. So that's why it doesn't matter if you include it or not include it. Okay. All right. So again, looking at this graph above, it's pretty easy to see when it's obviously decreasing and increasing. Yes. Something that you've done ever since, like, probably, honestly, maybe Algebra 2. Have you guys seen it in Algebra 2, maybe, I think? For sure last year, I know you guys saw it. But in calculus, we're looking, if we don't have a graph, what properties can help us determine if our intervals are increasing or decreasing. Okay, what I mean by that is if I'm given a function, f of x, we know it's increasing specifically when my derivative is positive. If I go back up here, the derivative of these blue pieces, right, the slopes of those lines, this is going to be positive, and the slopes of this curve are all going to be positive as well, right? So when my derivative is positive, that tells me that the f of x function is increasing. When the derivative is negative, if I took the derivative of this left piecewise function here, this would be negative, and all of these values would be negative for the slopes at those tangent points, right? So that would tell me that it's decreasing on our function, okay? So f of x is increasing when our derivative is positive, which you could also write as f prime of x is greater than or equal to 0. Okay, then f of x would be decreasing when our derivative is negative, or f prime of x is less than or equal to 0. Okay, so last class we talked about those extreme value theorems, so saying like where are my minimums at, where are my maximums at, looking at a graph, using those critical points, right? And we kind of tested some points on there to figure out what those are. So we're also going to use critical points to test to see where is my derivative changing from positive to negative. Let's look at an example here. So your critical point definition is up on top again. Important to remember, critical points are when the derivative is equal to 0 or it is undefined, okay? Derivative is undefined if things like wholes happen or if the denominator equals 0. That's when things happen when it's undefined. So looking at this first example here, we're given a function. Find any x values that would be a critical point for this function. Okay. Now, critical values is either going to be when the derivative equals 0 or when it is undefined, when the derivative is undefined. So first I need to do is find the derivative. If I find the derivative of this function, we're going to have to use low d high minus high d low, right? So h prime of x equals low d high minus high d low all over low squared. Did I lose you on the derivative?
Oh, I got like the same.
But then I can simplify this, right? So this would be x plus 2 minus x over x plus 2 squared, which equals 2 over x plus 2 squared, right?
Okay.
So that is my derivative. If I'm finding a critical point, that is either when the derivative is equal to 0 or when it is undefined. So it equals 0. If I set that equal to 0 and solve, what's going to happen? I can't, right? This never happens. We can't have a number down there and have it equal 0. Think about if I cross multiply. If I cross multiply this times 0, it's going to give me 0. 0 does not equal 2. That doesn't give me an answer for x, okay? So that's never going to happen. But what makes this undefined? Yeah, if x equals negative 2. If x equals negative 2, it is going to be undefined because that's what makes the denominator equal to 0, right? So your critical point is that x equals negative 2. It's also, if we think about it, this graph is again going to have a vertical asymptote, which we could have seen from this right here at the very beginning. If I were to graph that, I would have a vertical asymptote at negative 2. Therefore, it is undefined at that point, or not continuous. So that is one of our critical points. But we're not actually going to solve anything else from here, just getting some practice with that critical points, finding it. Example 2, we're given the derivative function. So do I need to take the derivative? No, it's done for us. I can set each of these things equal to 0. So I'm going to set x minus 1 to the third power equal to 0 and e to the 2x equal to 0. If I solve both of these, first one, I'm going to get x equals what? 1. What about the second one? Is there anything I can take e to the power of to give me 0? No. Okay, so this one I can't do anything with. Therefore, my critical point is just 1. Okay, this increasing and decreasing intervals is exactly what we wrote on the previous page. It says if we have a derivative that is greater than 0, it is increasing on the interval for our function. If it is decreasing, if it's negative, then it is decreasing on the interval of our function. So when we're finding our intervals of increasing and decreasing of a function, we've got 4 steps. Find the derivative. Find when is it equal to 0 or when is it undefined, or those critical points. And then we're going to create and make a sign chart to test our intervals. And we'll have to interpret that sign chart to tell me whether it is increasing or decreasing and give those intervals. Now, helpful tip, remember, if you're given a graph of the derivative, you don't need to create a sign chart because your graph is the sign chart, okay? We'll talk about that in a few examples. But we're going to start out with an easy one here. I've got a derivative, or I got a function, g of x, where I'm needing to find the intervals on when it is increasing and decreasing. So first thing I need to do is take the derivative of g of x. So g of x, g prime of x is equal to 2x minus 3. Okay, so when is this 2x minus 3 equal to 0? When x equals 3/2 or 1.5, right? So now I'm going to make a sign chart. Okay, this is the sign chart for g prime of x. I'm trying to look at what are my derivatives, positive and negative. And the only point that I'm going to have on this line is that critical point of 1.5. So now I just got to pick a point. Pick a point to the left of 1.5 if I pick 0. All I care about is the derivative. When I plug it in, is it going to be positive or is it going to be negative? So g prime of 0 is going to be 0 minus 3. Is that 0, or sorry, is that positive or negative? Negative. If I pick a point on the right of 1.5, say 2, g prime of 2, is that going to be positive or negative? If I plug in 2, I get 4 minus 3, so I get a positive. Okay? Most of the time it changes between positive and negative, but not all the time, and we'll see an example here soon of that. So I've got a negative side, I've got a positive side, and that should kind of make sense to us, because what does this function, g of x, look like? X squared minus 3x minus 21. That's a parabola, right? So I have a parabola here, and this point is that critical point of 1.5, right? So on the left side, it's going to be negative, it's going to be decreasing, and on the right side, it's going to be positive. So my slopes are all positive, okay? So I just got to write those intervals out. So for an increasing interval, it is increasing from 1.5 all the way to infinity. And then it is decreasing, starting all the way back at negative infinity and going up to 1.5. And this is of the function g. So g is increasing and g is decreasing on those two intervals. It's really important to make sure you're labeling your stuff so that you don't get confused, because when we start talking second derivative, we got to make sure we're keeping track of which one's what, okay? Questions on this one? All right, moving on, next example. Number 4, we are given a derivative. H prime of x is equal to x minus 2 times x plus 1 squared. Find the intervals where h is increasing and decreasing. So, do I need to take the derivative? No. I've given the derivative, so all I got to do is set this equal to 0. So, what values am I going to have for my critical points when I set this equal to 0? 2 and negative 1. So I'm going to have my sign chart, and this is of h prime of x. I'm going to put negative 1 and 2 on my sign chart. And we need to figure out where is it increasing or decreasing, okay? So go ahead real quick for me. Pick points on all 3 intervals to see, is it going to be positive or is it going to be negative for all 3 of those? And you're plugging it back in to your h of x formula. So you're doing h prime of a number to check and see, is it going to be positive or is it going to be negative? Okay, so test that out. All right, so when I evaluate them on the left side of negative 1, what did you guys get? Was it positive or negative?
Negative.
Negative. In between negative 1 and 2, positive or negative?
Negative.
Negative. And then to the right of 2? Positive. Okay, so this is an example of when you have 2 negatives next to each other. Let's think about what does that mean in terms of the function h of x. Anyone have any idea what that function h of x would look like if they're all decreasing? It's obviously going down, right? So like it starts by going down, right? But then let's say, okay, I get to this 1, negative 1, and then what happens? It's not an asymptote, but it's going to keep decreasing. And then it's going to get to 2, and it's going to start increasing. Okay? What'd you say?
What is delta zero? Like a negative 1?
At negative 1, it's not So yes, there's like, we call this like an inflection point. It's changing like from concave up to concave down, which we'll talk about next class. But this point is never actually like positive nor negative. Like it's always going to have a decreasing slope looking at all those values until you get to 2. Okay? This is kind of a sketch of what your h of x function looks like if you want to draw that on there. Just so you kind of have an idea of what this function looks like. And then we can go ahead and answer the question of, well, when is this function increasing and decreasing with my intervals? And we would say h is increasing on the interval from 2 to positive infinity, and h is decreasing on the interval from negative infinity to 2. We got some trig. K of x is equal to 2 sine of x minus x. Find the intervals where k is increasing and decreasing. And this time we have a specific interval we're looking at from 0 to 2 pi. So I'm not looking at infinity to negative infinity, just a specific interval. So first thing I got to do I need to take the derivative of this? Yes, got to take the derivative. So k prime of x is equal to 2 cosine of x minus 1. So if I set this equal to 0, I get my critical points, right? So set 2 cosine of x minus 1 equals 0. So that means cosine of x is equal to 1/2. So when is cosine of x equal to 1/2 on the interval from 0 to 2 pi?
Pi over 3.
Pi over 3.
Dang it.
And 5 pi over 3. Okay, so x would equal pi over 3 and 5 pi over 3 on that interval.
I'm going to draw it.
Yeah, you're giving it a circle.
On my notes thing.
Yeah, little circle. Yeah, that would actually be a great idea. Put the unit circle on your paper if you don't know it.
I have a question.
So we've got our x values, so now I got to test my points. Okay, so this is k prime of x. My test points are pi over 3 and 5 pi over 3. But I'm actually stopping at what 2 points? I'm not going forever, right? I'm stopping at 0 and 2 pi. Okay? So now I need to pick some points. And all I care about is it positive, is it negative? Okay, if I plug in a point in between 0 and pi over 3, we got to think about what value is in between 0 and pi over 3. Pi over 6. Let's do pi over 6. Okay. Pi over 6. If I plug that back into my derivative, so k prime of pi over 6. Okay. 2 times cosine of pi over 6. Is that going to give me a positive or a negative? It's a positive. Yep. And then minus 1 is going to give me a positive or a negative. It's going to give me a positive number. Okay? Now if I choose a point in between pi over 3 and 5 pi over 3, now we could choose pi over 2. Or just pi. Yeah, let's just do pi. Okay, if I plug in pi, cosine of pi, negative 1, right? So 2 times negative 1 is negative, minus 1 is also negative. And then again, you can't assume that the one on the right is positive, but we can check to see if it's positive or negative. Pick a point in between 5 pi over 3 and 2 pi. What's a number we can pick?
7 pi over 3. Wait. I mean over 2. Over 2. Wait, no.
Okay, let's think. 5 pi over 3 is the same as 10 pi over 6, right?
7 pi over 4.
Let's do 11 pi over 6. Yes.
I meant 7 pi over 4. Yes, I did.
So then if I plug that back in to 2 cosine x minus 1, am I going to get a positive or a negative value?
Positive.
It is positive. Okay, so now we just got to answer the question of when is it increasing, when is it decreasing. K is increasing on the intervals from 0 to pi over 3 and from 5 pi over 3 to 2 pi. And then it is decreasing on the interval from pi over 3 to 5 pi over 3. Are you laughing at my 3? Oh. Okay.
You're a very self-conscious person.
Nah, it's fine. My 3s are just, they struggle a little bit on the iPad when I write them.
Colin really just...
I know.
She's always asking us what we're laughing about.
All right. Because you're just sitting there laughing. I want to be in on the joke.
I thought you had like superhuman hearing.
Sometimes, some
You
days.
heard Danny.
So if we're looking at derivative functions, okay, little AP tip here, make sure you're looking at what it is. Is it the function f of x or is it the derivative function? If it is the derivative function, I know that my function is increasing whenever it is above the x-axis, right? My function is then decreasing whenever my derivative function is where? Below the x-axis, right? So on this graph here, it is increasing, since this is my derivative function. My derivative function tells me that my function is increasing anytime it is above the x-axis and decreasing anytime that it is below. Okay, so above is increase and below is decrease when we're given a derivative function. So that's what question number 6 is asking us to do, is just look at this graph above and decide what are the intervals for increasing and decreasing. Well, my intervals for increasing would be from negative infinity to what?
To negative 1.
To negative 1, and from 1 to positive infinity. And then it's decreasing, our f is increasing and f is decreasing from negative 1 to 1. Okay, same idea. Go ahead and look at number 7. Identify, again, where is your function increasing and decreasing? You're given the derivative function. Okay, so where is it increasing? Where is it decreasing for your function? So we should have gotten from negative infinity to 1 for increasing and 3 to 10 for increasing. Wait, yeah, that's right. Okay, and then decreasing is 1 to 3 and then 10 to infinity, yes? Okay, again, the hardest part is making sure you know, is it the function g of x or is it the function g prime of x? Which one are you given, derivative or regular function? Another kind of just, reminder of your notation and vocabulary is that these points right here where it changes from positive to negative on your derivative function, those values are your critical points, okay? So like x equals 1, 4, and 10, or wait, that's 3, sorry. 1, 3, and 10, those are your critical points. Okay, and your critical points are, again, where it changes in between that positive and negative, or increasing versus decreasing, okay? We got one more example here on the back page, and then we are done. So we're given a function y equals x plus 3 over 3x minus 1. Find the intervals where the graph of y is increasing or decreasing. So first thing we got to do is find the derivative. So go ahead and take the derivative of this function real quick, and then I will write my answer up here to make sure we're all on the same page. All right, did we all get negative 10 over 3x minus 1 squared? Yes? Okay, good. So now that we found that, we actually have to test some points still, right? Or find out what our critical points are. Now, if I set this equal to 0, what happens? I get nothing, right? That doesn't happen. So we need to look at, okay, well, when is it undefined? When is my derivative undefined? Well, when the denominator equals 0, right? So if I set the denominator equal to 0, what is my critical point? What does x equal? 1/3. Okay, so I'm going to test the point 1/3. And I'm going to plug in that value back into the derivative function. So this function right there. So to the left, let's pick 0. That's easy. If I plug in 0, I get negative 10 over 1, right? So it's a negative. If I plug in 1, I get negative 10 over a positive, right? that's going to give me still a negative. So I got two negatives.
Infinite negative.
Okay? It's infinitely decreasing for both intervals. However, 1/3, what is happening at 1/3?
It has the
It's undefined, which means it's actually having a vertical asymptote. So if you would graph this function, it would look something kind of like this, where you have a vertical asymptote here at 1/3. And if you look at it, all of these values, as you increase on your x, this is my function f of x, right? Or whatever it was, y equals. These are all decreasing, right? All of those y values are decreasing. Same thing here. All of these y values are decreasing. However, I'm not including that point at that vertical asymptote, right? It can't ever touch 1/3, so we can't include it. So when we're writing our answers for increasing versus decreasing, we're going to say this is a decreasing function. So y is decreasing from negative infinity to 1/3 and from 1/3 to positive infinity. Okay, we have to make sure 1/3 is not included in this case. So this is when it does matter if you have parentheses or brackets.
Might as well just never include it.
Yeah, always be safe that way. Yep. So on your homework, there's homework on the increasing, decreasing stuff. Answer keys posted. And then there is a mean value theorem extra practice. It's not a grade, but it is probably a good idea to try a few of them. Okay?